All right, so this week we're going to be focusing on databases and working with databases using SQL, so our SQL. So let's just get a quick intro into databases. Specifically, we're going to be talking about, um, what's the importance of databases. So a couple weeks ago, over the last couple of weeks, we've been using CSV files to store our data in our applications. So you remember, like going back to our school interface example, we provided student data in just a comma separated list. And that was a text file. That worked for our needs, but the question is, why is that not maybe an ideal form of persisting data? And why are databases basically a better way to, I guess, store your data? One key thing about databases is that they store and organize your information. So as opposed to just having text files that can be kind of arbitrary and kind of hard to manage, like imagine having like 20 text files that you just need to keep up to date. Databases are just a little more organized way of maintaining your data. And they also provide kind of like baked in security and just features that, yes, you can accomplish with your application, but if databases kind of provide that functionality already, that again, you don't need to reinvent the wheel there. So a few items that databases kind of features that databases provide. One is data indexing. So the idea behind that is if you think about having a CSV file, let's say, we had a student file that had maybe like 20 students in there, and we need to define a particular student out of that text file. Well, the current way we would access our CSV files would be read the entire file. And then once we have entire data, we could find maybe the item we're looking for. But that requires, again, reading through all the data in that file. Which is not really efficient when we're just looking for one particular item in that case. Databases give you data indexing. So basically all of your data records can be indexed. And when we talk about indexing, you just think of like having a list in Python, or I guess an array in JavaScript, where you have direct access to a specific index in that data structure. So indexing just gives you easier access to whatever you're looking for, as in you can directly go to it. You don't have to traverse a list or go through an entire file to find the particular data you're looking for, which is more efficient to retrieve data. Then we also have a notion of data integrity. So this is where we have, maybe stuff that relates to other items. So if we, for example, had a student file, as we're going with, and let's say those students were enrolled in classes. If we're keeping track of which classes they're enrolled in, well, we want to make sure that those classes actually exist, right? So like if, we had student like, Tony the Tiger, and he was enrolled in Baking 101, we want to make sure Baking 101 is an actual class that's offered by whatever school we're in, right? We don't want to just, give like text names for our classes and assume that they exist. So we might have a separate text file that represents all the classes we have in our school that we offer. Again, data integrity will just kind of automatically make sure that, hey, if Tony the Tiger is enrolled in Cooking 101, well, that should be a valid class, and that automatically will be checked by our database structure, assuming we structure it correctly. As opposed to if we just had text files, well, that's something that we as developers would have to manage. Like we'd have to check, all right, Tony the Tiger is enrolled in Cooking 101. We'd have to read our cooking, we'd have to read our classes file and make sure that Cooking 101 is actually a valid class that exists, right? That's, again, automatically kind of works behind the scenes, assuming that you design your databases correctly. Then we also have a notion of data validation. So, if we had a student file and we wanted to have like first name, last name, maybe like grade point average, that GPA should be probably a decimal number, right? We don't want, like, what if someone typing in data accidentally wrote like, a character in there, or just wrote like a word like good, bad, or whatever they might want to enter. They shouldn't be able to do that in an ideal world, right? We always want to enforce that we write like a decimal or a floating point number for their GPA, because that's usually how it's represented. With a text file, with a CSV file, our application has to do that logical check. With databases, the database will automatically ensure that whatever data type you specified for that field is actually entered. So if you try to enter like a string into a field that you said only should be a decimal value, well, then you'll get an exception back, so that you know that you haven't corrupted your data. As opposed to CSV files, again, you can enter anything you want. CSV files are just text files that accept anything you type into them. There's no, again, validation that's going on there. So again, databases make your data, again, just a little more secure from user error, especially in that case. Also, another very useful feature of databases is that they allow for concurrent access. So again, just think about your application scaling. Let's say we had just like CSV text files and multiple people were running your application. So let's say I was running my application. Let's say Sarah was running another version or instance of the application and Jack was running another instance. Well, we might get into an issue where if Sarah's trying to modify a user record and I'm trying to read that user info, we might get out of sync, as in I might load up my application and get that user, and then Sarah might write out to that user, and then my application might write back to it. So for example, so that was kind of a mouthful. Let's say I want to update a student's GPA, and then let's say Sarah wants to update a student's address, and they're both in the same CSV file. Well, if I try to go update GPA and write out to the file, and then Sarah only updates the address and writes out to that file, well, it's going to overwrite the GPA change that I made, because the way we write to CSV files, we basically read and write out the entire data, right? So it's going to basically wipe out the changes I had. With databases, you get a little more ability to kind of, again, access the data and write to specific values so that Sarah could update the address independently of me updating the GPA, because those are kind of separated out. Versus CSV files, you can do that, but it's a little more tricky, especially with what we've been doing where we just kind of append or overwrite the existing file. All right, so again, many advantages of using a database. Again, they are a little more complicated than just reading and writing to CSV files, but they offer a lot more structure and security, especially for large scale applications. So that's why databases are definitely preferred. And moving forward, we'll be storing persisting data in databases, because again, CSV files do exist in the industry. Like people still use like Excel and Google Sheets and just store all their data there. And they probably hand it to developers like, hey, here's our data, work with it. So you're gonna have to work with CSV files maybe on occasion, but hopefully for professional, well-established organizations, they're hopefully using databases instead of just relying on text files or CSV files. All right, let's actually talk about just a basic, I guess, file for a database is a table. So a table basically looks like a spreadsheet. If you kind of view it, you will have header information and then just values that go, that should be bugs, not bug. But yeah, then you have values in there. So this entire thing would be called a table. A field is basically values or attributes that you have for your data. So in this case, I have first name would be one field, last name would be another field, favorite food would be another field. All right, so the table data is actually the value. So the header is not actually part of the table when you're viewing it. Like it's part of the table structure, but the table data does not include the header. All right, so table is just the values you've entered. Each row of the table is called a record. So you might use these interchangeably. You might often they're just called records in your table, but just the normal way of thinking about it is just the row for each table. So, sorry, the row in each table. So Homer Simpson and donuts is an entire row inside my whatever table this is. I guess I didn't give a table name. And then you have field values, basically the column that you're looking at, whatever field, these are all the field values. So, Simpson would be the value for last name for the record of Homer Simpson. Right. We specifically deal with relational databases, also known as relational database management systems, or RDBMS. Relational databases are basically the common way to store your data. You can have non-relational databases, but I can't say I've encountered those personally. So it uses a relational model, and the whole idea here is kind of what we talked about before in our example, where we maybe had like a student's file and a classes file. There should be some relationship between those, as in, any information where like a student's enrolled in a class, that should be mapped to the classes table to verify that, that class actually exists. It's not a made up class. Also, relational databases use SQL. SQL is a standard language used. So SQL stands for structured query language. We'll get into that in a bit. Basically, SQL is just a standard used, by pretty much every database administrator. I guess you can have NoSQL databases. There's other variations, but again, relational databases are pretty much the norm, and SQL is the normal way to interact with them. So SQL is the language. Relational databases are the structure, or is the structure. Okay, so let's actually talk about some common relational database management systems you might encounter. These are a few of the popular ones. Again, there's a whole list of them, so this is not an exhaustive list. Postgres is very popular, and that is what we focus on in this curriculum. MySQL, also very popular. Oracle and MS SQL Server are more institutional size databases. So I use SQL Server in my previous role. SQLite is just, I guess, a very simplified relational database. It's actually like basically a text file, but gives you the capabilities of using a relational database with it. So again, these are just a few of the many they may come across, but Postgres is one of the most popular ones. So definitely going to be learning something that you might encounter in the industry. So let's actually talk about SQL. So again, database is just a way to store data, a little more advanced than text files. SQL is the way we interact with databases so that we actually get the relevant pieces of data that we want. Again, we don't want to just scan through all of our data in our databases. We should have a smarter way to access and manipulate the data. That's where SQL comes into play. All right, so what is SQL? SQL stands for Structured Query Language. As I mentioned, it's a standardized programming language used to interact with relational databases. The pronunciation, I'm not sure if there's one side wins over the other, but I've heard SQL. That's usually what I refer to it as, but you also might hear it as SQL. That's just reading out the letters. SQL is easier for me to say, so I usually say SQL, but again, you might hear either or. So take your side of the battle and I guess defend it either way you want. All right, let's actually get into SQL commands. So this is where, again, we're going to point you back to documentation. We've said that before, reading documentation is half the battle of being a developer. We're just going to go over some main commands that you're going to probably use. So create database and drop database. This is, as you might guess, is how you create a database in SQL and get rid of a database. So drop is to remove a database. When we're using Postgres, we could use our terminal to basically use the create DB command and the drop DB command. These are basically wrapper functions that will basically behind the scenes be calling a create database SQL statement and also drop database statement in the background. So again, for the most part, we're using create DB in our terminal, but you could do the same thing by calling create database with the database name and doing it yourself. So I think, as always, it's best to actually do this as an example rather than see the slides. So let's actually create a database. So I'm going to do it via the create DB command because that's the common way we're going to do it with Postgres. So I'm going to go to my VS Code, which I have up somewhere. All right, I'm going to use my terminal here. Again, you can do this outside of VS Code. I use the terminal in here. So in this case, I'm going to create a database. So let's type in the command create DB. Again, this is a Postgres command. So assuming you have Postgres installed on your machine. And then I got to give it a database name. So let's call it Monday, since today is Monday. And then hit enter. As per usual with the terminal, if you don't see any output, that's usually a good thing. So I didn't get any error messages here. That means this database was likely created, unless something crazy happened. But it looks like this created successfully. If I try to create the same DB, so let's run that command again. Notice I get an error. So in this case, if I did fail, I should get some prompts. In this case, I should create a database called Monday. Postgres is not going to overwrite that database. It says, hey, you already have a database called Monday. So, that failed to actually create the second time. If I want to drop a database, again, you can do that with drop DB Monday. And then if I try to create again, notice I actually created it because I got no errors. If you actually want to see the databases that you have on your system, you can do that through to your command line. So to do that, I'm going to type pSQL. So that's going to get into Postgres. And then here I could do \D. Again, you're going to read documentation for this. \D, I think, stands for definitions. No relations. That's not what I wanted. \DT. All right. That's not what I want either. I'm going to look this up. List of pSQL databases. All right, so again, documentation, great example. I have not memorized all my commands. Listing databases, \L is what I wanted. So if I do \L, all right, there we go. So I've had a bunch of databases I've created. Your output might be a little less verbose, but if I keep arrowing down, it'll show me all databases I've created. So I have, A3, A4, Amazon, some Django projects that had databases. So I'm looking here, there I go. Monday is the database I just created. So I do see it does exist. So I successfully did create it. Again, I have a lot of databases. I probably need to get rid of some of these that I don't use. But again, \L, if you go into pSQL, will show you all your databases. If I want to quit out of here, I could do, I think it's \Q. Yep. So \Q will get you out of the pSQL, I guess, kernel here, or the application here. All right. So I've created my database called Monday. Next, we want to actually create some actual data storage locations. So that's where we go to tables. So you can create tables. Again, tables are, you can kind of imagine them as files in your file system. So tables will store particular data inside of them. So you could create a table, you could update a table, alter a table, or drop a table. So these are the four main commands you'd see with tables. The create table is the one we'll probably be doing often. The create table has a syntax format of this. So create table, I have in caps. One thing I want to mention is that this is not case sensitive, meaning you could type in create table lowercase and it'll work the same. So usually I go with uppercase just because it's easier to read the commands versus the values. In this case, again, it's your option. If you prefer lowercase, you can totally go with it. So in this case, create table is my command. Table name is a parameter I'll need to pass in. So I'm going to give my table a name. And then parentheses to open the field definitions. So in this case, you'll provide a field name and a data type. So we talked about having data integrity. So you're going to have to specify what values the field can contain. All right, so a simple example, let's say we had a table of students we want to create. We'll do create table name of students. Usually you want to name your tables with nouns. So in this case, students, plural. And then I'll give it an ID. We'll talk more about IDs in a bit. First name, last name, and grade point average, I guess, are the items I want to store in this table. So notice I give it types. In this case, ID is going to be an integer. Serial is a special keyword that will auto increment your ID values for you. So you don't have to, again, specify what IDs, because you don't want them to collide. You should know how to manage them for you. So again, databases make it a little easier to create unique IDs automatically. So if you use serial, again, they'll just get the next available ID for you. Primary key, we'll talk about keys probably more on Wednesday, but effectively every table you create in a relational database must have a primary key. What a primary key specifies is that this field, or it could be multiple fields together, is the unique identifier for your table records. So again, imagine you could have a first name and a last name for a student that might be the same. Again, there might be two different, Bob Smiths that exist in the world or in your particular school. So using Bob Smith as a unique identifier is not going to be good enough. That's why, for the most part, you always use a numeric ID as a unique identifier. You could maybe think of exceptions to that, but for the most part, I'm just going to say always use an ID, even if it seems like it's unnecessary. For example, you might have, just say you have a table of, this is table of people that live in the US. You could use the a social security column as a unique identifier. In that case, again, social security numbers are meant to be unique, but there are some issues with that. Sometimes social security IDs can be reused. I assume that's been done in the history because when someone passes away, their social security number becomes available for reuse. So I'm sure we've had enough humans in the US, maybe we recycled them. Maybe not. I'm actually curious if that's true or not. But social security numbers have 10 digits. So that accounts for, is it 10 digits? Sorry, 9 digits. So that counts up to, I think, 10 billion people. If I did that correctly.
Ankur, I have a question.
Yep, go for it.
Did you just say that we recycle humans? Is that what I heard?
Sorry, we recycle social security numbers, not humans.
Okay.
As far as I know, we don't recycle humans.
But not both.
They're recycled for fraud.
Yeah, so I don't know about recycling humans. I don't know that industry, but social security numbers can be recycled in theory. So that's one reason you might not want to have a table that is keyed off a social security number, because what if you still want a historical record of all humans that lived in the US, because social security number is used in the US. If you still want that information, well, you're not going to be able to use that new recycled social security number for someone else. So again, usually always just create an ID field for your data is the main point I'm trying to drive across here. So primary key is, again, a predefined keyword. This is specifying that this field is going to be my unique identifier for this table. Again, this is required for relational databases, must have a primary key. Then you can have fields, and the fields will have a type. So in this case, I'm using a type of varchar. We can talk about that in a bit, but this is just a string data type that you can have. The 255 here tells you the limit, the number of text characters that you're limited to. So in this case, I specified in my table design that I want a maximum length for a first name to be 255 characters. That's probably on the excessive side. I've not met anyone that has that long of a name. There might be, rare cases where you might need to exceed that. But realistically, I probably could pare that down to like 64 characters or 60 characters, whatever I think is reasonable expected data size. Likewise, last name, I chose the same length. There's this not null here. So this is something we can talk about. So not null is specifying that whenever I insert a table record, I must have a first name. I can't leave that as kind of empty or null. So that kind of makes sense, right? When you enter a student record, you probably need a first name and last name. GPA, on the other hand, in this case, not null is not specified. So basically, this means that this field value can be nullable. So if I'm entering a new student and they don't happen to have a GPA, well, instead of defaulting to 0.0, like maybe I don't want that in my default, I can just leave that value out for my record, and that'll be totally fine. So this, again, goes back to data integrity and data validation. So if I accidentally try to enter a record without a first name specified, my database should throw an error saying, hey, your design says you need a first name and you've not provided one. Versus a CSV file, it's not going to check it for you, right? It's just a text file. So in that case, your application would have to do the logic of checking, hey, do you have a valid first name? Checking if it's within the character limits that you want. But again, databases kind of give you that already once you design your tables. So you don't have to keep checking each time you insert a record. All right, so let's actually create a table. So I'm going to create a table similar to this. I'm going to go back to my VS Code. And here I'm going to go back to the pSQL. I want to actually go to my database I created. So instead of going just to Postgres, I want to go to the database. I'm going to do pSQL Monday, because that's the database I created. And now I'm in my Monday database. So as my prompt says Monday. So here, if I do \D, notice it said did not find any relations. \D. Yeah. Okay, so this means there's nothing in my database right now. So I actually need to create tables so that my database actually has places to store data. So I'm going to do this command using my slides. So create table, students, I'm going to kind of run this and let's see what we get out of it. So I'm going to start typing SQL. So in this case, you can write SQL right in your terminal here. So create table students was the name of my table, parentheses, and now I specify my values. So let's go with ID, serial, primary key. And then what else did I have? I had first name. That was varchar. I'm going to make it 64 characters, just trim it a bit. Not null. Last name, varchar, 64 again. And what else do we have? I'm just going to call it GPA, just for a short form. This will be a decimal value, and that could be null. All right, so again, create table, open parentheses. I actually hit enter, so this actually continued. My statement, when hitting enter does not actually execute your statement until you add a semicolon. So even if I hit enter here, nothing's happened here. You got to use semicolons to as a delimiter to end your statements. So in JavaScript, semicolons are optional. In SQL, you need to have the semicolons to execute your statement. So this is spanning 3 lines, but if I add that semicolon, it's going to execute this entire statement here, excluding the Monday prompt. All right, so if I hit enter, notice it said create table. So give me some feedback that actually ran this statement. So now if I do \D, notice I get some information. I have a table called students. There's something else that got created. I didn't create it. This is something that Postgres is managing. Sequence that is coming from the serial keyword that I use. So whatever this is, I'm not going to ever modify it or touch it. But this will kind of manage the IDs, the unique IDs that you created for me. So again, serial automatically does that for me. And it has some table keeping track of that data. All right, so I actually have a students table where I can insert records. If I actually want to look at the data in there. Maybe getting ahead of myself, so let's go back to my slides. So we created a table. Let's talk about common data types. So there's, I think, at least 24 different data types you can have in Postgres. But probably the main ones you'll see are listed here. There might be a few others, but integer, int stands for integer. So int is a short form. Decimal is for floating point value. So again, GPA, if you want like 3.5, you need to have a decimal data type as opposed to int, which can only be like 7 or 5 or -3. Decimal gives you that floating point value. We'd have Boolean values, so just true and false values as a data type. Varchar and char, these are textual data. The difference between varchar and char. So char, you can have, if I go back to my, I guess I kind of lost it. Go back here. I can specify this as char 255 and it'll work exactly the same. The difference that you'll most commonly see varchar stands for variable character. This actually is space efficient. So if I enter a first name that is only 10 characters long, it won't take up a full 255 characters of space in the database memory. So again, this allows you to be much more efficient in terms of data size. Again, you guys might be thinking, well, that doesn't matter to me right now, but it's just every example we give, just scale it like times like 10,000 or a million, right? Like Facebook probably has 3 billion users or something like that. If they have 3 billion records and they're not saving that little bit of space, that little bit of space can add up. So almost always you're going to want to use varchar, and that just means that the size of this field will be variable to whatever data is stored in there. As opposed to char 255, no matter the value you have entered, that block of size will always be 255 characters long. So it just takes up more space. All right, so varchar is what you'll usually use for your applications. Yeah, so you can have char, but varchar is by far the more commonly used variable. You can also store time data. So timestamp will store date and time. You can also store date data or time separately. So again, common data types, there's a whole list of them. This is probably a great time to mention looking at documentation. So we say this often, that documentation is half the job. Postgres has amazing documentation. You will come across libraries or some other frameworks that you're using that might not really have any documentation or just terrible documentation. Postgres is by and far on the higher end of quality into the documentation. So if I search for, what was I going to search for? Data types. Again, their documentation is really well done. So definitely want to call that out for a job well done there. Postgres, I'm going to use Google. So Postgres, data types. Oh, you have better luck finding it. Yep, there we go. Documentation, data types. So if you go here, again, a lot of data types here. I don't even know what like circle is. Apparently you could store some circle on the plane. Never knew you could do that. You can store stuff in JSON format. We talked about JSON format earlier. But again, a whole list of data types that I'm not going to go over because there's a ton of them. But you guys can kind of explore if you're curious about all the types of data you could store. But these are the by and far the main ones you'll encounter. All right, so again, whenever you're creating a table, you need to create a column names, and then those columns must have a data type associated with them. Let's talk about accessing and manipulating data within tables. So these are the four main commands you'll use: insert, select, update, and delete. This corresponds again to the 4 main actions you can do with data. Insert, which means you're creating data. Select is actually reading data. Updating is what you might imagine is updating data, and deleting is deleting. So this is what we call CRUD functionality, and we're going to use, we're going to bring that term up again. CRUD stands for create, read, update, and delete. Then those are the 4 basic operations you'll do with any data. So insert is how you actually get data into a table. So let's actually use that right now. So if I go to my Postgres, I'm going to do insert into. So I got to specify what table I want to insert into. In this case, we only have 1 table in our database, but we still need to specify it. We could have more tables. So I'm going to do insert into students. So let's enter some student information. So I got to do values. Again, getting used to the syntax, not going to be easy. So looking up documentation is going to be common, especially early on. Values. So I had first name, so let's call Bob. Maybe we want to capitalize that, Bob, and then Smith will be a student. And in this case, I don't want to provide a GPA. I'm just going to do Bob and Smith. Let's see what happens. Okay, semicolon, insert into enter. So okay, in this case, it's trying to insert Bob as the ID. So in this case, I need to specify what columns I'm inserting into. So insert into students. And let me tell it what fields I want. So in this case, I want first name and last name. Again, the problem is I have ID as a field, and it by default it's going to think the first value maps to ID. So there's no idea of quargs. So I guess this is the quargs equivalent where you have to specify what field names you're trying to specify. In this case, first name, last name. So insert into students, specify the field names and values, and Bob Smith, and semicolon. Don't forget your semicolons. I forget it half the time. Okay, so we got an error. What do I have going on here? Insert into table name. Do I need to leave off the quotes? First name. Issue. Okay, so it looks like you don't specify quotes with field names. You just give it the name. So it inserted into that table. So if I actually want to look at that data, that's where we get to our select statement. Select is going to be probably your most used command. So definitely make sure we get familiar with it. So you're going to type select star. Star just means get every field that you want for that record. You can specify if you only want first name and last name, you can specify those fields. But you can use star to get everything out of that record. So select star from the table name. So in this case, students, my table name, semicolon, hit enter. All right, so I get all that entire table, all the records back from it. So in this case, I have ID 1. Notice I didn't specify the ID, that automatically got generated for me. First name Bob, last name Smith, and no GPA. Notice that's just a blank value, as opposed to like 0 or something other than that. There's no value here because I didn't specify it. It's effectively null. All right, let's enter another student. So I'm gonna go back a couple commands. So I do the up arrow, same thing with your terminal where you want to go back to past commands. So let's do Jane and Doe. All right, so I insert another record. If I want to see those, I'll do select star again. Notice I have 2 records now. Again, the ID is auto incrementing for me. I have the records here. Select statement, again, you can specify what column you want to extract. So I just do first name. I type in first name from students and semicolon. Again, I forgot it there. So enter that semicolon. All right, so in that case, my results are only the first name. So again, you could extract only the data you care about. You don't want to get all the data back, especially if you don't need it. So you specify column names if you don't want everything back. So if I want to do, let's say, first name and last name, separate with commas. So you could have as many fields as you want to specify. It's, again, remember that comma there, and remember your semicolon. All right, there we go. So we get first name, last name. Notice we don't have our ID or GPA in our result set. All right, so the select statement, again, definitely want to become familiar with that because it is by far the most used command you'll be using. So update and delete, I'm not going to go over examples with that, but basically update allows you to modify records. Actually, let's do an example since I'm going to mention them anyway. Let's say we want to update Jane's last name. All right, so let's say she got married, for example, and she took her husband's last name. So let's update that. So this we'll do an update command and then specify the table as always. So we want to update a record from the students table. And then we want to set last name. So this is the field we want to update. And then for, let's say in this case, we want to change Doe. Let's say she married someone named, I don't know, his last name of Gold. So we're going to set the last name to Gold. Let's say I execute this. Again, I know some of you guys are new to databases. Anyone have an idea what this command is actually going to do to my table?
I say it's going to change everybody's.
Yep. Tim's got it. It's going to change all records. So basically what this command is saying is search for your students table and set all fields for last name equal to gold. So basically Bob's last name will change to gold and Jane's last name will change to gold. So in this case, we're not really specifying which record we want to update. We're just saying do it for the entire table. Sometimes that might make sense. Like we might need to update every value for every record. So this is how you would achieve that. But we want to introduce a where clause. So the where clause, again, just another SQL keyword, lets you actually target rows based on some criteria that you want to specify. So in this case, I'm going to use a where clause and say where last name equals Doe. But that's probably not a great target because I might have multiple students that are named Doe. So this is, again, where unique identifiers make sense. So I might do ID equals 2, assuming I know the ID of the record I'm trying to update. So in this case, I'm saying only set the last name field equal to gold for the record that has an ID of 2. So in this case, Jane, if I remember from earlier, her ID is 2, and that should be unique. So no other record in this particular table should have a value of 2. So students table, whichever record has an ID of 2 should be updated to gold, and then semicolon. All right, so I ran that. Let's do our select statement again. All right, so notice that Jane's last name got changed to gold, but Bob's last name is still Smith. And just to highlight like the bad case or the incorrect case, where we're trying to do, change something, let's say silver. Let's say Jane's last name should be silver. If I do it this way and without the where clause, now I'm targeting every record in here. So if I run this and notice it says update 2. So it's giving me a summary of how many rows it actually updated. So that's giving you an indication that mobile things were updated. So in this case, both Bob and Jane's last name will change to silver. Any questions about inserting or updating? We'll get more into the select statement, but any questions? What questions do you guys have about accessing and inserting data into a table?
I do have a question, Arthur.
Go for it.
So what if, say you're trying to update something and you make a mistake? Is there like a revert method, or do you have to pretty much hope that you have a copy of your data before you changed it?
Great question. The short answer is not really. So if I made this change, I want to undo it. I can't just hit some command that will undo it. But with databases, so this is another feature of databases, there's an idea of creating transactions so that you can roll back a transaction if you run into an issue. We don't really cover that too much, but again, it is possible with databases. So you can kind of undo some actions if you package it in a transaction. So I'm not sure I've ever done it with Postgres. So transaction. So start transaction will basically attempt to do some stuff. So let's see if they have an example for us. Okay, so you use rollback. So if you start doing a transaction with a start transaction, so begin, they're trying to do an update and a commit. So if you want to undo it, it looks like you can roll back by saving a point. So it is a little manual process. There's no command Z to undo it, but it is possible. If if you think you might make a mistake, you can have save points with transactions and then roll back to them. So it does maintain the history somehow behind the scenes, but so yeah, it is possible, but we don't really do that, or we don't really go over transactions in our curriculum here. Yep, good question. Again, databases give you a lot of features that CSVs normally wouldn't. But yeah, so hopefully you should, for the most part, make sure you know what you're updating. So if you do make a mistake, it can kind of corrupt your data, and you might have to recreate your data or have some backup somewhere. Okay, so we covered updating. Again, we could drop records. Let's go with deletes from. Just get our syntax. So delete from students. Where. So again, I don't want to delete everything. If I just do this, this will delete all my students. So I do delete from students where ID equals 2. Notice it deleted one record. So it gives me a summary. If I run this again, notice I'm only left with Bob Silver, or formerly known as Bob Smith. All right, so just read documentation for this. So the syntax, again, use insert into, and then you give it a table name, and then you use the values keyword and then the values name. So again, you guys are going to have to look up documentation often, but if you look at insert statements, Postgres. So again, Postgres is just a different flavor of SQL. For the most part, it's going to be standard. As in, if you're using MySQL or Postgres or Oracle database, SQL, the SQL used with that should, for the most part, be the same. There might be a few edge cases where Postgres does something different or has some different syntax for a more obscure keyword, but the main keywords being like insert, select, update, delete, all those should behave the same and be the same syntax. So if I go to my insert statement, notice that you have a lot of options. So this is kind of hard to read, but insert into, give it a table name. Anything in square brackets is optional inputs. So again, these are all optional fields. So you can specify the columns. In particular, if you don't, it's just going to insert it into each column in order. So that's the issue I ran into before. Again, a lot of options here. So on conflict, so if you get a conflicting record, you could specify how to resolve that, as in keep the existing one, insert the new one. Again, many options here, so you guys can read this page. I'm not going to go over all the options, but it's quite detailed. They have good examples, so you can kind of run through that. But for the most part, just know insert into, give it a table name, give it column names, and then specify the values.
What if you have like multiple databases created in that folder? How do you specify which database you want to like insert into?
Gotcha. So currently I'm in my Monday database. So I think Musa's question was like, let's say I had a Tuesday database and a Wednesday database. How do I specify that I want to update only the table in Monday? Well, you need to actually get into their that database for updating it. So you can't just be like in pSQL and say, do a select statement for a particular table, because tables don't exist at the top level. The top level are only databases. You need to actually go into the database. Imagine databases as being like folders. So you need to actually go into a folder to find the files in it. There's no files at the top level. So there's no tables that just sit at the very top. But in this case, I went to my Monday database. If I want to go to a different database, I could hop out of this. Let's say I create DB Tuesday. All right, so I created a Tuesday database. So if I want to manipulate any data in that Tuesday database, I can actually go into that Tuesday database. So now I type pSQL Tuesday, and I'm only updating data in my Tuesday. So I do select star from students. I'm actually getting error because there's no table named students here, right? That table only exists in my Monday database. So it's not going to accidentally find it in Monday. My scope or my focus or folder is only everything in my Tuesday database. We do \D. Notice there's no relations, so we want to create a table quickly. Students. Say ID, serial. All right, let's just give it an ID. Right, and then \D. Oops, sorry, DT.
Serial is spelled fine.
Oh, sorry. Indeed. So let's drop that table. Table is created. Drop table students. Oh, I forgot my semicolon. So doing some bad examples here. All right. Creates table students ID serial primary key, and the magic thing I forgot was a semicolon. So it actually didn't run this command because I didn't put a semicolon. So lesson learned. Again, I forget them often. You guys might forget them. Hopefully you guys are better than I am. But if I run this, try and make that clear. Nope. All right, so this clear should not be there. All right, create table. There we go. So I created a table now. So I do \D. There we go. So it has that students table. So now my Tuesday database has a students table, and my Monday one does. But I actually just care about my Monday database right now. So pSQL Monday, and we're back in our Monday database. Okay, so let's talk more about the select statement. So that's the one you're going to be doing probably most often. These are clauses you can have within your select statement. So we talked about from briefly. From just specifies which table you want to extract data from. Where is your criteria or your condition? As in, if you want to target a select row, your where is kind of how you go about specifying which exact row or records. You can have multiple records you're updating at one time. It doesn't have to be one record. But your where clause is what specifically is going to control what is being targeted. You can also have aggregators. So group by is the keyword for that. And then having is basically the same thing as a where clause, but the having only applies to your group by selections. Distinct, so you can get multiple records back that are identical. Distinct eliminates those duplicate records. And then order by lets you sort your results, and limit will limit your results. So let's say you have a query that's going to return 1,000 results potentially, and you only care about the top 10. You can sort like by ascending or descending and only get like 10 records back. So let's actually try to do more complicated queries using these clauses, but we need more data for that. So let's actually create a new table and go from there. All right, so go back to my SQL here. Create some space. All right, let's create a new table. I'm going to do create table. Let's call it Oscar and values. All right, so in here, I want to give an ID serial. I'm just going to do something a little different, actually, just to get some more variety in here. I'm actually going to drop out of my pSQL. So do \Q. I'm going to go to VS Code. So this is my preferred way of writing SQL. You can do it in your terminal, nothing wrong with that. But I like having the GUI and just having a file. So in this case, I'm going to create, let's call it oscar.sql. So notice my icon changes to a database because VS Code knows this is a SQL file. And now I get some syntax highlighting. So it's kind of more friendly than using a terminal, in my opinion. But I can write SQL here and then eventually run it using Postgres in my terminal. So I'm going to write some commands here. I'm going to do create table. It's called Oscars. And I'm going to add some columns. Let's do ID serial primary key. Again, always need a primary key for your tables in a relational database. Let's do first name, varchar 64. Last name, varchar 64. Let's do not null. I have my first name nullable, just to get some variation. Let's do favorite food as a value. Let's do varchar. Let's have that be 64 also. All right, so very simple table, just first name, last name, and favorite food for now. I'm gonna save that and semicolon. So now I have SQL written here. I can have more statements written after this. Again, each line will be executed in order. So let's try doing that. Let's insert some records. So insert into Oscars. We want some column names. So first name, last name, and let's say favorite food. Values. All right, so let's get some information from our students. Alex Saunders, you're first on my screen. Do you mind sharing me your favorite food?
Yeah, Mexican.
Okay. Alexander Saunders. One thing I want to mention, very important, I make this mistake a lot. For SQL, you have to use single quotes for strings. You cannot use double strings. You're going to get some errors if you use double strings or double quotes. So again, in JavaScript and Python, we've said that you could use single quotes or double quotes interchangeably. In SQL, that is not the case. That's a big important note. I want to make sure I mention that because I've definitely made a mistake. I'm like, why isn't my SQL running? Always use single quotes for string data. Okay, so I'm using single quotes here. So hopefully that should be good. Saunders, and I believe it's Mexican food. I love Mexican food also. Let's just Mexican food. And all right, and then semicolon, let's get a couple more records here. So I'm going to do this all in one file and then execute it all together. So who else do I have here? Musa, do you have a favorite food you can share with us with the class? All right. Oh.
Have you just jollof rice?
What was that? Fries?
Jollof rice.
How do you spell that?
JOLLOF. OF.
Okay, I've actually never heard that.
OF.
Oh, yeah. Jollof?
Rice.
Right. Okay, sorry. All right, cool. I had to look up that dish. But okay, so we have a couple records. Let's actually just go with this. And all right, so now that I have my SQL in this file, if I want to execute this in Postgres, I type pSQL, the database I'm operating on. So in this case, I still want it to be in Monday. And I use this caret characters. Basically, I want to feed this file into my Monday database. So I'm going to do that caret for the less than symbol, and then just give it my file name. So in this case, it's oscar.sql. So basically, it's going to run each of these line by line. Hypothetically, if the first one fails, these will fail also. But hopefully, I don't have any errors here, but we'll find out. I'm going to do Oscar SQL. All right, so it did all three items. It created a table, insert a record for Alex's information, insert another record for Musa's information. All right. Cool. All right, so we got that table going. Let's say we want to add information. So we can modify tables. It's not always the easiest, but it is possible. So there's an alter table statement, which can alter the structure of your table. So in this case, I've specified 4 fields. Let's say I want to add a new field, like let's just say calories for that favorite food. Column name is getting kind of wieldy. Let's make this integer. So I use int or integer. And okay, so we want to specify how many calories our favorite food has, right? In this case, I can't run this command again because the table already got created. So there's 2 ways I could go about this. One way is that I could drop my table, as in delete this table, and then recreate it. The problem with that is I'm going to lose the records that I had in already. So I'm going to lose Alex's and Musa's information that I had in there already. So you probably don't want to drop your table entirely because you lose all the data. So the better way to do it is using alter table. And this lets you, again, modify your structure so that you can, for example, let's say Oscar's is my table name. And then I want to add a column, right? So basically my new column, I need to specify the column name. So let's copy it. Or actually, I can do this here. So let me get rid of this. Let's do alter table Oscars. Add column. Again, you can write this all in one line. Like there's nothing wrong with writing add column on one line, but it's just easier to read by putting on a new line. So add column, and then we'll do favorites, food, calories, we'll call it, and then data type. So in this case, it's an int. I think that's the syntax for it. Let's give that a run. Let's find out. So I'm going to run this SQL file again. So pSQL Monday Oscars should update the existing Oscars table. If that didn't exist, I'll probably get an error, but we already created that table. So let's run that. All right, so notice we got alter table feedback. So that looks like that was successful. So I go back to my table definition. So I go pSQL Monday and then type \D for definitions. So I have Oscars. If I want to get information on Oscars, I think it was \DT Oscars. How do I see table information? pSQL get table field names. Again, I don't remember all my comp. So it's like D plus. So I think \D plus table name, Oscars. All right, there we go. So again, I'm constantly looking up pSQL commands. I don't have memorized. I wouldn't expect you guys to, but in this case, notice I looking at the definition for Oscars. I have an ID, which is an integer. My first name is a character varying 64. If I go down more, notice I got this favorite foods column added, which is an integer. So that's what we did with our alter table statement. So if I go back to doing a select, so let's get some space here. Select star from Oscars. Notice I get this column that has no value in it because I add a new column, but I didn't specify what values I wanted to add there. So let's say we want to do an update. We could do update Oscars where sets favorites food calories equal to, I don't know, what's an average calories Mexican food dish? Let's say it's kind of high.
5,000.
1,000.
Yeah.
I'd say no, it's good.
1,000. But again, I need to specify where. So let's say where ID equals 1. Semicolon. All right. So if I do this, notice we get 1,000 for Alex's record. All right.
Question. How would you set a new column that has a not null property?
Yeah, so you can do that with alter table. So we want to alter, let's say we want to add favorite color. This will be a string, so do varchar 64. You can specify not null, but question you might have is, well, if you try to create this, all the existing records are gonna be null. So that's gonna be a problem, right? Yeah, so alter table statement is probably one of the most complex. There's a lot of items to it. You can specify a default. So in this case, set default, something I haven't talked about before, and then you give it a value. So in this case, let's say default for favorite color should be, let's just say rainbow will be a default color. All right, so now we're saying this column can't be null. Because of that, we need to specify a default. So in this case, every item will default to rainbow, and then we can change it later. So if I run that, assuming I'm not lying to you, run this. So it's saying this field is going to be not null, but also there's going to be a default value of rainbow. Okay, looks like I screwed that up. Set type. Need to change these. Set defaults. Maybe the set is my problem. Okay, sorry. So not set default. My notes may be wrong here. Default. So default rainbow. If I run this, run my select again. SQL. I want to go into Monday. Table was Oscars, so select star from Oscars, semicolon. Okay, notice the default value is rainbow. So it's still null, as in we can't have a null value, but we specify what default should be. So you can do that if you know what default you want to insert. Otherwise, yeah, you can't really create a null value, a null column without knowing a value to kind of go in there already. So we have these records, but let's say, let's enter a new record, and then we'll talk about some design decisions that we made. So insert into Oscars, value, column names. So I want to do first name, last name, favorite food. Let's copy these. And favorite color. All right, let me quickly put in some information here. So values will be, use my name. So again, single quotes. I always default to double quotes because that's my preferred way. So I get in trouble. Favorite food. Let's say I happen to like Mexican food also, which I do. I wouldn't say it's my favorite. I think pizza has just that comfort spot for me. But Mexican food, let's say Mexican food is my favorite. And then 1,000, because that's how many calories we were saying that it has. And then my favorite color, FYI, is actually dark gray, which is probably not a common favorite color, but I seem to like it. Not sure why. And then add our semicolon. Let's get out of here. Run that. I got inserted. SQL Monday. All right. So let's talk about this quickly before we move on from this point. From Oscars. All right. So we got this record. Can someone tell me something they might notice from this design? I know it's a very generic question. What's maybe kind of wrong about this, what I have designed here?
The ID is not in numerical order.
Yeah, that is true. So by default, your table can have any order. They don't have to be sorted. So in this case, I think they got swapped because I updated Alex's record when I entered the calories. So yeah, the table got out of order, but that's fine. Tables don't have to be ordered based on any particular ID. You should not expect them to be ordered, in fact. So don't rely on that. But yeah, that is a good observation. Let's think about back to our OOP talks about.
You've got attributes of food in the people's table.
Yeah, so I guess what I'm trying to get at, I guess my question wasn't well worded. The problem, so this works, right? This is accurate information. Mexican food, like, is my favorite food and Alex's favorite food. So this is right. Like, there's nothing wrong, inherently wrong with the data that we have here, but the design has some questions to it. Namely, Mexican food and calories are tied together in this case. So like if jollof rice also had like specific calories, let's say an average, like a serving size of jollof rice had calories of 500 calories. That information is tied together. But in this case, we're repeating ourselves. So the dry principle is being violated. We're repeating data here where we have Mexican food and 1,000. These two are paired together. So anytime, let's say I'm adding a new record for like Don, and let's say Don happens to like Mexican food also. Well, we're gonna have to enter Mexican food again and 1,000 because we're just saying the serving size of Mexican food is always 1,000, right? So we're gonna have to repeat that information over and over. So this actually points to our table design is actually not proper because we have user information, then we're kind of combining other information here. So this is, again, not the best relational database way to design your code. The proper way to do it would actually be, we should create a new table. I'm gonna call it foods. And this will be a new table that's gonna relate to this. But again, this is very, very similar to OOP design. So you likely will see an overlap and you will have to use that same side of your mind when you're creating tables. So in this case, I'm gonna create ID serial primary key. And this kind of, you'll see this very often where you just have an ID that is your primary key using the serial keyword. Let's say food name. That would be varchar 64. I default to 64. Again, that's not a magic number. Let's say food calories. And this will be an integer value. Okay, I could add more, data here, but now I have my food properties kind of tied together. So this is, if you envision OOP design, I would have a separate foods class from like a user class. In this case, I call it Oscars. But the user information should be separate from foods because, again, the food item can exist outside of a user or an Oscar student existing. Those are separate entities or separate concepts. So you should imagine them as separate classes in your code or separate tables in your data. Again, very similar lines of thinking there. So now all this food information is tied together. So once I create that table, I could insert into foods. Let's just do one record. I'm not going to go wild here. Let's do food name and food calories. Values would be Mexican food. And we said 1,000 calories per serving size. All right, so now that I have this, let me enter that. Let me run that quickly. Values, okay, so that inserted. Okay, so I got an error because the first time I ran this executed, but I got an error with this line. So that creation failed, but then I was able to insert. So all is fine, even though this error happened. Like it just failed at recreating the table, which is fine. So that food tables exist. So now this is the whole idea between relational databases where I want my Oscars table to have some relationship with the foods table. So currently my Oscars table, if you remember it, P-SQL. That'd be a way to get to database. I'll just do it the way I know how. P-SQL Monday, and then I want to do select star from Oscars. All right, so again, we have these columns. Again, this is not the proper way we'd want to go about doing this. So instead of having the food information here, we should just link to this table. And the way we link to it is via the unique identifier. In this case, the primary key of the foods should be the only piece of information we store in the Oscars table. That is separated out. So now we should actually drop these columns. So there's a way to do that in SQL. Let's do alter table Oscars, drop column, and that's favorite food and favorite food calories. All right, so we just want to remove that data from our table and give that a run. SQL Monday, let's feed it our SQL file, oscar.sql. Not do it together. All right, looks like I gotta do one by one. Surprising. Calories. Okay, so those tables should no longer exist. So I go back into pSQL Monday / or select star Oscars. Okay, so notice those columns got deleted. Now we actually want to store the information by using something called a foreign key. So a foreign key basically says, I want to reference some unique identifier from a different table. It usually is a primary key, but it also can be a unique constraint, which we haven't talked about. Again, this will be talking more about on Wednesday, so I want to keep this kind of introductory. But the whole idea here is I want to alter table Oscars. I want to add a column, add column, and we're going to call that, it's called favorite food ID. And that's going to be an int and foreign food. I actually haven't done this way, so I might run into issues. Foreign key, references. We want to tell the table to reference. So in this case, foods is our table, and I'm going to look up documentation. So Postgres alter table foreign key field, and I should get some good Postgres documentation. So alter table, a lot of items you can do. So I want to do add column constraint is what I'm looking for. So let's look for that. So create table foreign key. So column name references table. Okay. So I want to give it the column name. In this case, the column is favorite, just ID, and the table is food. So this is basically saying the ID column from the foods table is what this column is going to point to. So this again gives us some data integrity in that the food must exist in our data for us to actually reference that favorite food. So if I do this, and let's hope it runs. Foreign key. So I want to add column type, column constraint.
Didn't appear to have parents around the key.
What was that done?
Is my audio better, by the way?
A little. Your voice is a little faint now, but
I turned the volume down. It did not appear to have parents around the key
around the key.
or around ID.
Oh, I think that's required, but we could try it without it. I think my syntax is just a little off, but always worth trying. Yeah, so I think I need to do it a little differently. So add table constraint. So maybe add see if that's what I want. Oh, all right, so I gotta look at my syntax. So I'm doing, again, add column type, column constraint is what I'm trying to do here. Add column. Let's go here. What was before? References table. Foreign. Do I need to swap these?
Yeah.
Okay, so again, my main goal is to reference some other table, which is foods that I created, and a column within that table of foods. So hopefully this will work. Oh. Add foreign key alter table. All right, Stack Overflow. So let's solve it for us. So alter table, add foreign key. Okay, so yeah, so that's by the column and then a constraint separated. That's where I was. So I see. So my syntax was pretty bad. So this is going to be an int, and then I need to add constraints, and then foreign key. So this column is my foreign key. And I'm going to reference some other columns. So references, foods, and ID. All right. So again, syntax kind of hard to memorize, at least for me, but that's where documentation hopefully should save you. I'm trying to add a connection via foreign key. So foreign key just says use the key of some other table. So in this case, favorite food ID from my Oscar table is going to reference an ID from foods. So if I do that and run that, nope, that still didn't work. Almost maybe. All right, this is not going well. Add to integer.
Do you need to put column there?
Pretty sure I do, but maybe not. So it might be Postgres specific, so that might be different syntax. Postgres might just move on from here, but we're doing alter table, table name, add column, column name, data type, constraints. All right, I'm kind of struggling here, so I don't want to take up too much more time. Let's just kind of go past this point. But basically the idea here is there should be an ID in your user table that points to your food table, because your food table has additional information about foods. You shouldn't store all the food information together with your users, because that can lead to repeated code there. All right, so again, we use from and where. Again, group by lets you aggregate, so some aggregation functions. You can use average, count, minimum, maximum. So for example, if you want to average like the calories for your food table, you can do that via average. That'll give you one value back for all the records of your table. Talking about where, just talking back. So where you could do comparisons. Key thing to remember, just a little different than JavaScript or Python. Use a single equal sign to do a comparison. You don't have to do double equals. So single equal is not going to assign a value. Equal in your comparison. Doing an equality comparison, use a single equals mark. Also, you do less than or equal to, greater than. For doing not equals, you see either or. So you might do exclamation mark, equal sign, or angle brackets kind of opening and closing with one another. This is also for not equal. Other words you might use, in and not in. So if you have like a collection, you could use in or not in, sort of similar to Python. Between, so if you have a range, let's say you want to find food items that have calories between 500 and 1,000, you use the between keyword to kind of do that for your where clause. Like and I like, this is where you can start getting into using regex. So like for string data, let's say I want to find users that have a last name that start with the letter S. I could do that if I have my database still kind of going here. Let's go into pSQL. Nope, that's not what I want. pSQL Monday. Let's say I want to do select everyone from Oscars where last name like S percent sign. What this is saying is get anyone that has a last name that starts with S and anything after it. Percent sign is a wildcard. So if I run that, notice I get, I guess all of our last names start with S. Let's do first name. There's an accident there. So first name, like, hey. So now it should only get Alex in my record. Musa should not be in here. because from this query. So it's not going to remove them from the table. It's just only going to get usernames that start with letter A. Okay, so notice we get Alex, and I have 3 records of myself because I think I screwed something up before. But yeah, so like lets you do some regex with strings. Similar to lets you actually use regex. So again, regex we talked about before can be useful, especially with doing SQL queries. Instead of having to get complicated where clauses, you can use regex to kind of simplify those queries. Again, we talked about aggregate functions. So if I want to aggregate, I guess my food items only had 1 item. So let's do insert into foods, food name. I gave it calories, values of let's just say pizza, and slice of pizza maybe has 500 calories, maybe. Okay, so I inserted it. So now if I want to do an aggregate search, I could do select to and then we could do group by. So group by is an aggregator, and we'll do average. Oh, sorry. We'll do average PVG food calories from Oxford. So this again is going to sum up everything and then average the food calories. It's going to be 1 record that I get back. Not from Oscars, from foods. So notice I got 750 back because I had 1,000 for Mexican food and 500 for pizza. So it accumulates all the data information for that field. In this case, the field of food calories, and gives me the average back. So again, it can automatically do it for you instead of you having to compute it yourself. Group by lets you create buckets. So let's say we had different types of pizza. Let's say we had like pepperoni pizza, cheese pizza, and mushroom pizza. We could create different buckets for those if we had like different information for those types of pizza slices. All right, so let's finish up our talk about relational tables by relation types, and then again we're going to go more over this on Wednesday. So I know this is kind of speeding through it, but just kind of keep in mind there can be different relation types between 2 different tables you have. Your relation type can be 1-to-1, 1-to-many, or many-to-many. So the classic example I go to is think about a school. Let's say you have a student table and a class table, or a classes table. So like, or courses, let's call them courses. So let's say, a student table might have Musa as a record, might have Alex as a record, might have myself as a record. In that case, and we have a courses table. So if you think about, sorry, I'm gonna need more tables in my example. Let's say we have an instructors table also. So let's say my name is an instructors table and Tom's name is an instructors table. For a course, usually you have 1 instructor. So in that case, you have a 1-to-many relationship where 1 instructor can be an instructor for many courses. So let's say there's multiple courses in our curriculum. Let's say we have like biology 101, cooking 101. 1 instructor, like myself, I could be an instructor for a cooking class and also an instructor for biology 101, assuming I was qualified for those. In that case, I'd have an instructor table and have a relationship to the courses table that's 1-to-many, meaning that I have many, I could teach many classes, but only 1 instructor per class. 1-to-1, that's a case of like our favorite food example. Actually, that's not a good example. 1-to-1. Maybe think about addresses. So let's say I have an addresses table and I have a students table. 1 student might have 1 address and I might store that address table in a separate place. So in that case, that'd be a 1-to-1 mapping, as in 1 address corresponds to 1 student and 1 student corresponds to 1 address. Many-to-many, that's the example I was trying to go with before, is where you have courses and students. 1 student can be enrolled in multiple classes or many different classes. Likewise, 1 course can have many students enrolled in it. In that case, you get a many-to-many relationship. When you have many-to-many relationships between tables, you need to create something called a join table. And we're going to go over this on Wednesday, so I'm not going to get too detailed into it. But to kind of accurately represent that many-to-many relationship that you might have between 2 tables or 2 entities, you need to create a join table or an intermediary table that will kind of reflect that relationship. If you have a one-to-many or one-to-one or one-to-many, you can use foreign keys to accomplish that. All right, one-to-many is foreign keys. One-to-one would be a different kind of constraint. But yeah, in that case, you don't need extra tables, but many relationships, you will need to create extra tables. We'll talk more about this on Wednesday, so I don't want to get too into that right now. Important notes that I kind of mentioned. Don't forget your semicolons at the end of SQL statements. I drop them half the time, and then you're like, why? Nothing happened. What? Like, why is that? Usually, most of the times, you just forgot a semicolon. Also, just to reiterate, use single quotes for string data. Do not use double quotes because that means entirely something else in SQL. All right, so that's, again, basic introduction into SQL. Just get familiar with using these statements when you create tables. So insert, select, update, and delete are probably your most common items you'll use. Just get familiar with also creating tables, so know the syntax for it. Give it a table name. Make sure you give it a table or field name and a field type. So that's, again, you need to know, the database needs to know what type of data you want to store in each field. All right, know how to create a database. So using create_db or drop_db in your command line, assuming you have Postgres installed. You could also write SQL queries using create database or drop database and appropriate syntax with that to create those databases. All right, what questions do you guys have about anything we went over here? Kind of get familiar with these 7 clauses you can have in your select statement. From and where are commonly used. Grouping and having. Having is a little more rare, but that is useful when you use group by. Order by, again, you could specify like ascending or descending if you actually want your results sorted. Otherwise, there's going to be no default sort from your results. So again, get familiar with these 7. You'll see those here and there. Any questions?
I don't know.
Sorry, I heard something.
Can you use like the delete method? Can you use it to delete like portion of the table? Like if you want to delete like a row where it says favorite food, if you want to delete everything from that table.
Delete is to delete records. If you want to actually remove a value from a column, that's where you do an update. So you do update, favorite food set value equal to null. So that means there'll be no value stored for that. But you want to do delete for particular records. If you want to remove a record, you use the delete command. So delete command to remove a record. If you actually want to modify a specific value, use update. Even if you want to, like, quote unquote, remove a value or set it equal to null, that's where you use update.
So delete is for like if you want to remove like a particular person.
Yep, you got it. Delete removes an entire row from your table. Update modifies that row. Select just gives you the data back from your table. Insert inserts a new row. So just, again, imagine like a CSV file, it's just a new record that gets inserted. All right, with that, I'm going to stop the recording.